Thank you for the presentation, Mr. Chairman. First, I would like to thank the organizing scientific committee the invitation to attend this conference. In fact, I know my background on compositional data is not is limited, but I believe that it is worth to promote the use of this new statistical tool because till now is not extensively known. I'm going to show a little because we are over time more or less. Then I'm going to go quickly. Well, first I would like to think a little about what is a composition, a table of composition. A table of composition has three main characteristics. All the values are positive values. The second, the amount, the absolute amount depends on the reference amount we are taking into consideration. And third, there are no independent values. They are bounded because when, for example, you change the amount of measure, the proportion of measure, you have also to readjust the rest of the concentration. Then they are not independent variables. They are bounded variables. The same happens, for example, when you are analyzing the fat from table olives. You have a list of components and the final concentration, according, if they are estimated according with the International Olive Oil Council, the amount should be around 100. Then it's also a bounded composition. If you change any concentration of fatty acid, immediately all the other fatty acids, the concentration are readjusted. How are these statistical, how these data are treated statistically? Well, they are treated with the conventional statistical we are accustomed to use, which were developed mainly for independent variables, not for bounded variables. The situation is not important when you are applying just trivial analysis like ANOVA, general model, and so on. But when you are applying other more sophisticated tools like principal component analysis, clustering, and so on, then you may have some problem, as I'm going to tell you immediately. We were suspicious about the what kind of treatment give to our fatty acid composition, because we were used to work with mixture of salt. With this mixture of salt, we were always analyzing them in the simplex. But we then looked at the reference on the literature and found that Pearson, a long time ago, wrote a paper on a form of spurious correlations. Then the problem is not new. We are just carrying it from a long time ago. We had a revision of the references in order so that other researchers were concerned also about this problem, and as a result of all this consideration, we assume, according to Bogart and Tolosana Delgado, that most of the varied methods developed for real data are misleading or inapplicable to compositional data because, among other reasons, independent components mixed together and close exhibit negative correlation. We found this very frequently in our analysis. covariance between two components depend on which other component are reported in the data set. Variance matrices are always singular due to the constant sum of constraints. Components cannot be normally distributed due to the rounded range of values. Then, it's clear that the habitual composition, the habitual statistics are not appropriate to treat data of composition. In my opinion, this is an example of the application of the normal statistic to composition. This is, sure. Okay, this is the table of the International Oil Council for the categories of different olive oil. All of them are established in percentage. What happens if you change the percentage of any other fatty acid? Automatically, the others also change. Then, this is not inappropriate, in my opinion, this is not appropriate table for establishing limits. Well, there were many researchers working on the problem, and finally, the main impulse of this compositional data analysis was given by Aitchison, who established that composition provides information about relative, not absolute components. Therefore, every statement about a composition should be stated in terms of ratios of components. And as a result of this, there were a lot of the introduction of a lot of low ratios transformation for the treatment of composition. Then, in agreement with this definition, it is clear that all the limits established in the International Olive Oil Council should be established as ratios, not as percentage as it is right now. Well, people continue working in this field, and well, from the beginning of this century, they recognized that some of the operations in the could be like internal simplicial operation of perturbation, the external operation of powering, and the simplicial metric define a metric space. This is a new metric space, but define a metric space. This space was the simple, and they realized that most of the problems found previously in relation to the analysis of composition could be solved by a state in the simplest. Which are the basic principles? I am not going to explain a lot, just 3 basic principles of the compositional data, just to show you how different is this in relation to the habitual statistics we are used to study in the school, at the university, and so on. This is a completely new branch. The principles are completely different. Compositional data can be defined as part of some whole which carry only relative information. This is the basic principle of compositional data. Only carry relative information. Everything should be stated as ratios, not in absolute values. All proportional vectors are compositionally equivalent. That is logical. It doesn't matter if we express the composition per 1 gram or per 100 grams. Each equivalent class represents only one composition. If which is the usual representation of this composition, the usual space for this representation is the simplex. As far as I know, nobody is using this representation right now in composition. How can we analyze the composition? Well, there are two steps to analyze composition. The first step is just stay in the simplest, because statisticians have developed a lot of tools just to work with composition in the simplest. In fact, there are almost any tool in the normal statistics have another one in the compositional data analysis. Then you may estimate central value, you can make test of normality, estimation of variation matrix, binary partition, and so on. And then there is also some ratios that allow projecting the composition into the simplest with one less dimension. And the characteristic of this projection is that the coordinates are already in the Euclidean space. And then you may apply to them all the normal statistical tools now available. Well, let's go now to apply it very quickly to one example. This is one example taken of one of our experiments. We use here two cultivars, manzanilla and hojiblanca. We gave them a normal Spanish style processing. There we have 4 levels in the treatment: fresh fruit, light treated, fermented, and packaged. And we study the composition in each of these combinations. Well, I have reduced and changed a little the table just to prevent a problem of copyright and so on, because publications are very strict in this sense. And, well, I would like to fix you on the amount. The amount are close to 90, but are not the same. Are not the same. Then what is the first step we have followed when using compositional data analysis? The first step is just to close the composition to the same amount, because before there was one with 93, 94, 90. Now, after the closure, all the composition of the treatment have the preferences to the same amount, 100. Okay? Obviously, all the composition, all the values of the composition have changed to accommodate to this new reference value. Well, as I told you, the statistic is different to any other one. Then, for example, means that has no any meaning in this new statistic. The standard deviation, the same. But instead we have new statistics. For example, the tendency, the central tendency is measured by the center. The center is just the geometric mean of the composition. And obviously it's different to the mean. This is the center of the table, the composition I told you before, and this is the average, the mean. They are completely different. An important step also is the estimation of the correlation, because all the multivariate analyses are based on correlation or covariance. Then, here we can see the correlation. The correlation between two similar fatty acids. In the case of raw data, the correlation is about 0.5, and in the case of closure data, the compositional data, it is about 0.9. The matrix of correlation is completely different. Then if we base our studies in these matrices, then we are going to reach probably different results. That is obvious. In this analysis, one of the first thing is just the variance matrix, the variance array matrix. It is this one. There is just the variance of the log ratio, because all the statistics here in this new statistic is based on log ratio. Then this variance is referred to the log ratio. For example, this is the log ratio of this fatty acid with this other one. Then what is the interest of this log ratio, of this variance array? Well, it is because it said us which are the relationship, the ratio with the biggest variance, with the highest variance. And they could be the most interesting to detect any effect of treatment or any effect of cultivar and so on. Then this is almost a first step to select those ratios with more greatest interest for us. As in the case of the normal statistical analysis, we have also tests to check the normality of the data. Here in this case, we can see that our data are normally distributed. This is the application of one of the typical statistical tools, but in this case, this biplot is particularly made for compositional data analysis. Among other characteristics, for example, in the interpretation, you can see that the distance between arrays is approximately the variance of the log ratio of these two components. Then, this is completely different. This interpretation is not allowed in the conventional statistics. This is a form by plot, also built specifically for compositional data. Here you can see a perfect segregation between cultivar, because this form by plot preserves distances. There is a very good separation between cultivar, but there is no segregation due to treatment. Well, this is another characteristic of the new statistic. We are all going to represent this in the simplest, not in the normal axis. This is the presentation of the as a function of the four fatty acids with the highest variance. Then they will be able to separate as much as possible in this case, the cultivar. As you can see in the center presentation, the center plot, they are perfectly separated regardless of treatment. We also can perform principal component analysis in the simple, and it is interesting for looking for any linear relationship between composition. In this case, it is clear that the composition of manzanilla and hojiblanca follow a linear relationship following the trend of PCE1. This is one example for what I was talking in relation to relationship or balances or partition. This is very complicated. I'm not going to explain it, but I would say that this partition is important for two things. Just for build a new dendrogram. This dendrogram is absolutely new for compositional data, and it represents at the same time the balance. The balance is the relationship between one or several group of components with relation to others, and also the distance, vertical distance is the variance. Then you can see in a side, in a view, the relationship between this component and also which relationship has the highest variance. This is according to treatment. Well, it is also interesting to compare how are the results obtained with application of the conventional multivariate analysis to the raw data and also to the transformer data. In this case, we can see that there are clear differences between the dendrogram obtained with raw data with respect to EL coordinate. These are a kind of transformation that it is usually used. Then the great distance, the great dissimilarity corresponds to cultivar here. And also there is a clear difference between using one and another type of that data. It is better see here. In the case of EL coordinate, there is no any wrong assignation on the case of hojiblanca cultivar, but in the case of raw data, there is one wrong assignation in the first cluster, and also the clustering of manzanilla are better organized using EL coordinate. Then, in general, in this case, one can say that the result obtained a little better. With respect to the application to the same the PCA to the two different dates, we also obtain similar result, but here you can see that the difference between cultivar is greater than in the case of used raw data. We are now applying this statistic, the new statistic, in our research. We have already published some paper on this issue. One of them is in relation to the fatty acid profile. The another one is in relation to the volatile profile of green Spanish table olive. And as conclusion, I will say that Euclidean space is not the simple space for compositional data, not the composition of olive oil, not the composition of olive fat. The sample space for compositional data is the simplest. The compositional data should be analyzed bearing this consideration in mind in always using procedures in agreement to the data structure. Compositional data analysis has developed numerous exploratory tools and advanced procedures that allow, while staying the simple, obtaining new and valuable information that could be of interest for an appropriate interpretation of results. Working in coordinates, the second phase, may allow also a better or at least similar result than by applying the conventional battery or multivariate method to coordinate. And therefore, I suggest the application of this new statistical compositional data analysis to composition. In relation to the olive oil, I believe that this can be, the new statistical tool can be also applied. And, for example, among the effect, you can express the result in a different way and present the data also in a different way. Maybe you may produce better estimation better the effect of cultivar, region, treatment, and so on. Discovery of new relationships, because all the relationships in the current standard are not scientifically chosen. Yeah? This proportion is always below tal and so on, but no, you are not sure that this component has the highest or suffers the highest variance. Also, there is possible to find different or new relationship among olive oils, and it is possible also to detect new frauds and changes in the olive oil legislation. To finish, I would like to pay a tribute to the few persons that are now developing composition and data analysis, except me, because they have developed a lot of tools during the last 2 decades to develop a new, entirely new branch of statistics, which is a very, very valuable effort, I believe. Thank you very much for your attention.
Thank you, Mr. Fernandez. Thank you very much for your presentation.
Okay.